Subnetting 101. Let's get into it. I'd like to start off by explaining ones and zeros in binary. 1 means it's turned on, 0 means it's turned off, and in an IP address, there are 8 bits in an octet. And those 8 bits has a place value. So depending on where it lies in an IP address, so let's say we'll continue with this 1, 0 thing here. 1, 0, 0, let's just say these are all zeros. So if we saw a string of 8 bits like this in an octet, what does that mean to us? Well, depending on where it's placed, it equals a value. So because we care about ones means it's turned on, which we need to take note of, that equals 128. So if I kind of just transcribe these zeros down here, if we have a 1 here, that means the subnet mask is going to be a .128 or a /25 for CIDR notation. CIDR notation means how many ones I have in the subnet mask. All right, so let me clear this off real quick. And let's say, what if I had a /27? What does that mean? That means I have 27 ones in the subnet mask. So by default, a class C IP address has a /24. So how many ones are we going to have in the 4th octet? Because 24, if you divide that by 3, let's see, divide by 3, that equals 8, right? All right, so 8 bits per octet. But we have a 27 here. So what is 27 minus 24? Should be 3. Equals 3. So that means that we have 3 bits in the 4th octet turned on. Everything else is 0. So with a /27, we see that the subnet mask is a .224. All right, so what does that mean for subnetting? Well, the place where you stop borrowing host bits, let's say that right there, that number, that 32, let me change this color right here. That 32 means that you will start rotating subnets by that number. All right, I'll say it again. Where you stop borrowing bits, you can see here it stops at 32. You start rotating subnets by that number, by 32. All right. How do we do that? Well, let's take a look at this IP address right here. 192.168.1.17 with a 255.255.255.240. So we have our little chart here for the subnet mask, and we just start placing ones till we get to 240. All right, and then everything is zeros. So where we stop borrowing host bits are represented with zeros. Networking or subnetting bits are represented with ones. So we actually stopped right here because this subnet mask told us to. So we borrowed 4 bits, and our rotator, or our rotation of subnets, are 16 IP addresses. So where does this IP address lie? That .1.17? Well, this is where we have to start at 0 and start rotating by a number of 16. So if we start at 0, rotate by 16, so that means the next one's 16, and then add 16 again, 32, add 16 again, what is that, 48, and you get my picture, right? You just keep rotating by 16. And you look at that last octet of that IP address that this subnet mask is referencing. So it shows a 17. So 17 is 1 above 16. So let me write 17 right here. So this IP address belongs to this network, the 16. So it'll be 192.168.1.17. 168.1.16. And don't forget the subnet mask, so that'll be a /28. So if you were to be asked a question, what is the subnetwork ID, or what is the network ID of this IP address based on this subnet mask? Well, you have to find where you stop borrowing bits, find the rotating number, and then find where that IP address lies. So let's do this next question right there. We have a /224, and the last octet is a .100. So let's find out what our rotator is with this /24. 1, 1, 1, because that's where it equals 224, and all zeros here. 0, 0, 0, 0. All right, so we see that our rotating bit, or our rotating number, is with 32. So we start at 0 and just start rotating by 32 until we find where 100 lies in between. So 32, 64, what is that? 96, 128, and I think we're good. So 100 lies right in between 96 and 128. So its network that it belongs to is the 96 network, because 100 lies in between it. All right, everyone following so far? All right, good. So let's go to the last one. We have a 252 in that last octet, and it's referencing this 135 address. So let's find out what our rotator is. We start applying ones till we get to 252. Right there, bam, and bam. So our rotator here is 4. So how do we tackle this? Well, we could just start at 4, or start at 0 and start rotating by 4, but as you can tell, that's going to take a lot of adding here. So there's actually a trick. When you get to the smaller numbers, each number to the right can fit into the number on the left. All right, so 4 will fit into 8, 8 could fit into 16, 16 can fit into 32. So we could easily skip numbers here. So since 4 goes all the way into 128, you could actually do the division right there. But 4, if you keep rotating, will always hit 128. So I could actually jump all the way to 128 and start rotating from there. It's almost like a easier way to get to the higher numbers. So then you just start adding 4 from there. 128, what is it? 132. And then add another 4, 136. All right, so let's clear this off right here actually. So that was our rotator here. So 135 lies right in between 132 and 136. So that means the network of that IP address is a .132. Okay? Oof. So that is how you find the network of an IP address based on the subnet mask that is given. Now, based on all of that, you could also get a little bit more information on that. So where the last bit is that is turned on, where the last 1 is, this will tell you how many networks you can get out of it. This will give you how many valid hosts you can get out of it. So if you say, all right, I have a /30, how many networks can I have? I could have 64 of them. How many hosts can I have? I could have 2 hosts. In this formula, 2 to the h minus 2, we minus 2 because you have to save IP addresses for the subnet, the subnet ID and the broadcast address. So that's why we have to do this -2 here. This chart can be used to help study for Sec Plus Subnetting goes a lot deeper into it, but if you're just trying to find a quick way on how to find the network of it, the network of an IP address, um, then this is the easiest way. Clear all this off, memorize this chart. Remember, this row right here is the bit value, and the subnet mask, every time there's a 1 there, you just add it up. You just add it up. So 128 plus 64 equals 192. 192 plus 32 equals 224, so on and so forth. So this is how you can calculate the subnet mask and what that actually means. So I hope you guys can use this chart. This is a good chart to reference. I know that there's a lot of numbers in there, but if you just continue practicing subnetting questions, then this chart right here can be very useful. There are some subnetting websites that you can go and use, but just there's so many out there, and I'm not going to prefer one over the other. But if you just Google subnetting or subnetting problems or questions, I'm sure you could find some good websites out there. So I'm going to be doing more subnetting videos. It's going to be more in depth, but if you just want to get a quick look at Class C subnetting, this chart will do it for you. We'll get everything done. So I hope this was informative for you, and I'd like to thank you for viewing.